Alright, problem 25. We want the indefinite integral of x times the cosine of 3x dx. And I look at this, and we should look at this and see, okay, a cosine of 3x and x, I don't have an antiderivative. I can't go straight off to the antiderivative. I don't know what has a derivative of x cosine of 3x dx. So that's a problem to begin with. So let's try the second sort of level when I'm doing integrals. If I try to use substitution, so first off, we don't already know. So we don't already know the antiderivative. Okay, that's a problem. And then we can try the second level, I think, of difficulty of time-consuming parts, and that's u substitution. And if I tried u substitution, if I tried to replace something, my best bet is to make u equal 3x. But if I go ahead with that and take the derivative, I still have an x left out here. It won't actually cancel. You can go through that if you really like doing u substitution. That's not going to solve it. So that's no good. So both of these options won't work. Let me put x's there. Those red x's make it clear that it probably doesn't work. So we need to do something else. Integration by parts. And we look at this now, and I have x cosine of 3x dx. And my integration by parts rule, let me try to get this nicely drawn with all sorts of colors. So integration by parts basically says that if I have the integral of u dv, then that will equal u times v minus the integral of v du. And what's really nice about this, I see that I go from u to the derivative of u. And if I take the derivative of x, I'm left with 1. That'll take care of part of this. I go from dv to v. I'm going to have to do an indefinite integral. I'm going to have to go back a level from this. But if I go back a level from cosine of 3x, I just get to sine 3x over 3. So that doesn't hurt. So let's get started. It looks like it's going to work out. And let's see what happens. So we'll let u equal x. We'll let dv equal the cosine of 3x dx. And later on this side, I'm going to need to know what du is. So if I take the derivative of both sides here, I'll get that du dx is equal to 1. And if I use differentials, I'll see that du actually equals dx. Multiply both sides by dx there. Over here, I have dv equals this, and what I'm going to end up doing, I'm going to erase it to make it neat, but what I'm going to end up doing is I'm going to actually take the integral of both sides. I'm not going to put a plus c in here yet. We'll just bring one in at the end. But I'm going to take the antiderivative of both sides to get what the value of v is, because I need that on the right-hand side. So we'll get from that v is, I could use u substitution. We should know a rule for this. Basically, if I have the cosine of any constant times x, the antiderivative of that will be the sine of that constant times x, sine of 3x, divided by 3. It's sort of the opposite, the inverse chain rule. If I took the derivative of this sine of 3x, I get the cosine of 3x multiplied by the derivative of 3x, which is 3, and they cancel out. It all works out. Okay, I have everything I need to do integration by parts correctly. So let's see what we've got. We have our original problem. I'll rewrite it just to make sure everything is clear. Our original problem was the indefinite integral of x cosine of 3x dx, kind of rhymes, 3x dx, is equal to, and now I'm going to use integration by parts here. So this here is u, this here is dv, like we already set up. So I have u times v. Well, u is x. V is sine of 3x divided by 3, so x times the sine of 3x divided by 3 minus the indefinite integral of v du. So I have sine of 3x divided by 3 and du gives me dx. And now I just have to do some tidying up of this. It's actually pretty close to being done. So the first thing, I'll multiply this x to the sine of 3x. I might need to do some cleaning up to make it look like these answers, but if I multiply those through, I'll get that this is then equal to x sine of 3x over 3 minus, and this is kind of ugly, we could take the derivative straight away, but I always like pulling out constants to make my life easier, so I have this divided by 3, this 1 over 3 term, so I'll take that out, 1/3 times the integral of sine of 3x dx. I'm running out of room over here. Okay. And now I have this integral of the sine of 3x, but I know what that is. It's the same rule we had to take the antiderivative or the indefinite integral of the cosine of 3x. So the antiderivative of sine is negative cosine, and we have this kx, so I have negative cosine of 3x divided by 3. So this right here becomes negative cosine of 3x divided by 3. And at this point, I've taken care of all of the integrals over here, indefinite integrals. I need to bring in a plus c. There always was this arbitrary constant implied throughout here when I had integrals, but now they're gone, so I have a plus c. And I bring down everything else. I have this 1/3 multiplied to this. It's multiplied to the c as well, but 1/3 of an arbitrary constant is another arbitrary constant, so we have a plus c here. And let's bring down everything else. So equals, I still have x times the sine of 3x divided by 3 minus 1/3 times the negative cosine of 3x divided by 3 plus c. Let's bring it all together, and I'll just write it all in yellow because yellow is pretty. And I get x sine of 3x over 3 minus 1/3 times negative cosine 3x over 3. The minus cancels out to plus. The 1/3 and the 3 down here are going to become a 9th on the bottom. The cosine 3x is left on the top. And I still have a plus c. And let's see what we've got. So 3x sine of 3, no, it doesn't line up. We don't have the things in the denominator, don't have the 3 and the 9 down there, and that's not it. We don't even have a cosine term here. That's not. This one looks pretty good, except, so we have the x over 3, but we don't have the divided by 9 under this cosine, so that's no good. X sine of 3x plus c, we're way off, way off. X over 3 sine of 3x. So I didn't write it that way, but I could bring the x over 3 out to the front. Plus 1/9 cosine of 3x. This cosine of 3x divided by 9 has a 1/9 term, and I can bring out that out to the front. Plus c. My answer is E.